Hello everyone, welcome to Talk on Civil Engineering. Let us discuss about flanged sections. So here flange sections are nothing but the T-beams and L-beams. So usually if you are designing for a flange section, those will be more economical and effective. Okay. So what is flanged sections or what is T-beams and L-beams? So here if you see, usually when you are going for a construction, the slab and the beams are constructed at one time. Okay. So the formwork is provided. The formwork will be same for slabs as well as and beams. So these are the same formwork is provided for slabs and beams at one time, and even the concrete is poured at one time itself. Okay. So since these slabs and beams are constructed at one time, so these slabs and beams will work monolithic. So they act like a monolithically. That means like a one unit, they will act like a one unit. Okay. So since they are casting at one time, so since they are casted monolithically, so they act like monolithically, right? So for suppose here you can see, so here you are having beams. So this is a beam here. So this is a beam here, and this is a slab, right? And these are the columns, right? So if you see at the end of the edges, some here, so here somewhere here this may be your beam portion. Okay, so this may be your beam portion, right? So this may be your beam portion. Okay, so this is another beam. So let us take this as a beam 1, and this is a beam 2. So this is a beam 2. Okay, so for suppose if I take a cross section over here, so let us take a cross section over here. So I'm taking a cross section at the center of the slab. So if I take a cross section here, how it looks like? It looks something like this, right? So it looks something like this. Okay, so these are the beams, what we have called the beam 2. Okay, and this is a slab. Remember, where is our section? Our section is at the center. So this is our section. Our section is at center. Okay, so ikkada cut chesi center lo cut chesi nenu chustunnanu, right? So center lo cut chesi, this is how it looks, right? So this is a slab and this is a beam. Okay, so some portion I have told you. So if you cast like this, so since you are casting beam and slab at one time, so some portion of slab will act as a beam. Okay, so let us consider this portion of slab. So this portion of the slab is acting like a beam. So entire this section will be a beam. Okay, so how it looks? It looks like a T-beam, right? So this is a T-beam. Okay, so here also some portion of the slab will acts like a beam. Okay, and here also some portion of the slab will acts like a beam. Okay, so here, so since it looks like a inverted T, so it is inverted L, so it is a L beam. Okay, and this is T beam, so it looks like a T, so it is a T beam, and this is a L beam. Okay, right? So if you take a single beam, single T beam or L beam, so the cross section of single L beam or T beam, so it looks something like this. So here you have reinforcement. So this is called effective width of flange, denoted with small bf, and this is called depth of flange, Okay, so here this is called flange. Okay, so this is called flange, the horizontal member. Then vertical member called web. So this is called web. Okay, and so this will be the width of web, and from top to the center of the reinforcement, it is the effective width, effective depth. We all know this. Okay, so these are the basic terms that we'll see in the flanged sections. So similarly in L beam also. So in L beam also, so this will be your effective width of flange, and this will be your effective, sorry, this will be your flange depth, and somewhere here you'll be having the steel, so this will be your effective depth. Okay, and this is your width of web. Okay, this sometimes it is called as web, or sometimes it is also called as rib, right? So these are the basic terms that we are going to see in your flanged sections. And coming to the effective depth, so here BF is called as effective width of flange. Okay, so to calculate this effective width of flange, so usually here you see I have told you, so this is your effective width of flange, right, BF. So we need to know how much of slab, is acting like a beam. Okay, so ఎంత వరకు స్లాబ్ ఎంత డిస్టెన్స్ తీసుకోవాలి అనేది మనకు తెలిసి ఉండాలి. అంతే తెలిస్తేనే we can calculate this BF, right? So in order to calculate this BF, that is effective width of flange, so IS 456 has provided few empirical formulas. So using that empirical formulas, we can calculate this effective width of flange. Okay, so this effective width of flange is calculated using empirical formula provided by IS 456. So let us see what are those empirical formulas. Yeah, so if you open your IS 456 page number 37 and clause 23.1.2, so it deals about the effective width of flange. Okay, so here you're having effective width formulas. So for T beam, so for T beam, the effective width of flange is equal to, so this is a formula, so BF is equal to L0 by 6 plus BW plus 6 DF. Similarly for L beam, so this is a formula, L0 by 12 plus BW plus 3 DF. Simply for L beam, so we are taking half of T beam, that's it. Okay, so half of T beam in the sense, so half of L0 by 6 will be L0 by 12, right? So L0 by 6 into 1 by 2, so it will be L0 by 12. So similarly half of 6 DF will be, so 6 DF divided by 2, so it is 3 DF, right? So half of T beam's width will be half of L0 beam. So but you have to use formula. So remember this formula. So in order to remember this formula, I have told this concept. Okay, so L beam formula L beams ki effective width formula గుర్తుంచుకోవడానికి T beam formula గుర్తుంచుకుంటే మీరు half చేస్తే you will get the L beam effective width formula. Okay, and so these two formulas is for continuous beam. So like beam that which we have discussed just now. సో ఇలా కంటిన్యూగా మీకు ఎల్ బీమ్ టీ బీమ్ ఇలా కంటిన్యూగా బీమ్స్ ఉన్నాయి అనుకోండి, ఇలా కంటిన్యూగా ఉన్నాయి అనుకోండి, దెన్ యూ కెన్ యూస్ దట్ ఫార్ములాస్. ఇఫ్ ఫర్ ఐసోలేటెడ్ ఫార్ములాస్, ఐసోలేటెడ్ బీమ్స్ లైక్ సజ్జాస్. సో సజ్జాలు ఎలా ఉంటాయండి? సజ్జా లేకపోతే సన్షేడ్. సో ఇలా మీకు డోర్ ఉందనుకోండి, ఇఫ్ దిస్ ఈస్ అ డోర్, ఓకే, దిస్ ఈస్ అ డోర్. సో హియర్ ఫ్రమ్ సపోర్ట్ టు సపోర్ట్ యూ విల్ బి హ్యావింగ్ అ బీమ్. ఓకే, సో బీమ్ నుండి మీకు ఇలా స్లాబ్ వస్తుంది, రైట్? సో బీమ్ నుండి ఇలా, ఇది బీమ్ అనుకుంటే, సారీ, సో దిస్ ఈస్ అ బీమ్. Okay, so this is a beam, so something like this you will have a sunshade. So this is a sunshade. Okay, so now if you see here, this is a isolated L beam, right? So isolated L beam. So here this is the L beam. Okay, and this is the span of beam. So this is your span of beam. Okay, so since this is a isolated L beam, so for isolated L beam, IS 456 has provided separate set of formulas to find out the effective width. Okay, so here, so these formulas, these two formulas is for isolated beams, isolated T and L beams. Okay, so in isolated T beams, mostly you will see in case of bridges. So bridges ఇలా ఉంటాయి కదా, సో ఇలా స్లాబ్ ఉండి మీకు సెంటర్ లో బీమ్ ఉంటుంది. ఓకే, సో దీస్ ఆర్ ద ఐసోలేటెడ్ T beams, right? So for isolated T beams, these two formulas you have to use to find out the effective width of flange. Okay, so here what is here BW, you know, BW is the width of web, and DF, what is DF? DF is a depth of flange, and unknown term is L0. So what is L0? So L0, so here look here, so L0 is the distance between points of zero moments in the beam. Okay, so the distance between the zero moments of beam is your L0. So that means, for suppose if you consider a simply supported beam, so for a simply supported beam with UDL, how will be your bending moment? So bending moment will be something like this, right? So this is your support. So at support, you know, the bending moment is 0, and at another support the bending moment is 0. So at both the supports you will be having the bending moment 0. So between the distance between these 0 moments is your L0. So this is your L0. Ante for simply supported beam, so your L0 is equal to L. So L0 is equal to length of span, ఎందుకంటే సపోర్ట్స్ దగ్గరనే మీకు 0 మూమెంట్స్ ఉంటాయి కాబట్టి. ఫర్ సపోజ్ ఇఫ్ ఇట్ ఈస్ అ ఫిక్స్డ్ సపోర్ట్, ఇప్పుడు ఫిక్స్డ్ సపోర్ట్ అనుకోండి, సో మూమెంట్స్ ఎలా ఉంటాయి ఫిక్స్డ్ సపోర్ట్ కి? సంథింగ్ లైక్ దిస్, ఇలా ఉంటాయి మూమెంట్స్. సపోర్ట్ దగ్గర 0 ఉండదు, సపోర్ట్ కంటే కొద్దిగా ముందే మీకు మూమెంట్ 0 వస్తుంది. బియాండ్ ద సపోర్ట్ యూ విల్ గెట్ 0 మూమెంట్స్, రైట్? సో హియర్ యూ ఆర్ హ్యావింగ్ 0 మూమెంట్, and here you are having 0 moment. So this will, the distance between these two will be your L0. Okay, so for a fixed beam, or for a fixed beam or a continuous beam, so your L0 will be 0.7 of L. Okay, so this is given by IS 456 itself. I will show that. Even if it is a cantilever, how your bending moment diagram will be there. So for a cantilever, your bending moment diagram will be something like this. Okay, so here you are at the free end the moment will be 0, and another end the moment is not 0. Okay, so what is the distance of 0 moments? 0, right? So for a cantilever your L0 will be 0. Okay, because the distance between 0 moment is 0. Okay na? So ikkadne only at one place the moment is 0, at the other end the moment is not equal to 0. Okay, so for cantilever beams, your L0 is equal to 0. Remember that. Okay, right? So here in the note he has mentioned that for a continuous beam and frames, the L0 may be assumed as 0.7 of the effective span. 0.7 of the effective span. Okay, so for a continuous beam and frames, the L0 may be assumed as 0.7 of the effective span. Okay, so here in the note he has mentioned that for a continuous beam and frames, the L0 may be assumed as 0.7 of the effective span. Okay, so for a continuous beam and frames, the L0 may be assumed as 0.7 of the effective span. Okay, so here in the note he has mentioned that for a continuous beam Okay, so remember this is the effective span, not the clear span. Remember that. Okay, effective span in the sense center to center of your beam. Okay, so center to center of beam, you have to take that span. So this is the effective span, right? So this is how we can find out the effective width of the flange. So you, in the questions, in the exams, he may ask you to find out the effective width of the T-beam or L-beam also. So try to remember these values. In the next class, let us see the analysis of these T-beams, how we can find out the movements and the steel required for these T-beams and L-beams. Thank you all.